Stage 4 of model-based inquiry is called building consensus. This stage marks a shift in the unit, from investigating ideas through tasks to working collectively to decide how the class explains the anchoring phenomenon. Up to this point, students have generated ideas, tested them with evidence, and revised their thinking. In Stage 4, the goal is to bring that work together across groups and across tasks so the class can move forward with a shared evidence-based explanation. Building consensus builds directly on the work of the previous stages. Students first created initial models early in the unit, then revisited those models midway through Stage 3 as they worked with evidence from multiple tasks. By the start of Stage 4, students have engaged with new ideas, completed additional investigations, and accumulated substantial evidence. Here, evidence is broadly construed to include both qualitative and quantitative forms generated during Stage 3 tasks, such as data sets and science ideas that students have taken up in their sense-making. As a result, further revisions to their models are needed. This stage begins with groups returning to their models one final time, using what they now know to refine and complete their explanations. In Stage 4, students finalize their group models in small groups of 3 or 4. This is not a cleanup step or a formality. It is a continuation of sense-making through the science practice of modeling. Students are still working to figure out how to explain the phenomenon through group modeling as a sense-making practice. In the Hindenburg unit, this means groups revisiting how they explain the rapid ignition and destruction of the airship, refining how they represent energy transfer, chemical reactions, and ignition sources, using evidence from the Exploring Energy Lab, among others. In the Lamsilis muscle unit, students return to their models of lure evolution, clarifying how variation, selective pressure, and reproductive success work together across generations. Modeling here functions as a knowledge-building practice. As students revise their models, they clarify their thinking, negotiate meanings, and integrate ideas that may not have been possible earlier in the unit. These final group models offer teachers a powerful window into students' understanding, and they serve as important artifacts for the collective work that follows. Once group models are finalized, they are shared with the class. At this point, the teacher plays a key role in selecting and sequencing models for discussion. In the Hindenburg unit, the teacher might foreground differences in how groups explain the role of hydrogen versus external ignition sources, or how energy transformations are represented. In the Lamsilis muscle unit, differences might center on whether groups emphasize individual survival, population level change, or the role of host fish in shaping lure traits. Rather than treating all models as equivalent, the teacher intentionally foregrounds these differences. Through whole class discussion, students compare models, question one another's reasoning, and engage in argumentation grounded in evidence collected across the unit. This process supports the class in negotiating which ideas best explain the phenomenon and why. Consensus does not mean everyone's models look the same. It means the class reaches shared agreement about the core ideas and evidence that matters. A central feature of Stage 4 is the co-construction of the Gotta Have checklist. The goal of the Gotta Have checklist is to build a consensus list of the important science ideas and facts that need to be present in a gapless, evidence-based explanation of the anchoring phenomenon. As a public record, it makes this shared agreement visible and available to the entire class. In the Hindenburg unit, this might include ideas such as the storage of chemical energy in hydrogen, the conditions required for ignition, and evidence from the Exploring Energy Lab that supports claims about rapid energy release.
Pretty short and sweet and to the point, okay? And so we could see how if that was kind of an introductory sentence in our evidence-based explanation, you then would need to get into, okay, how do you know it was exothermic? And talking about the release of energy, then bringing in the definition of exothermic and endothermic, okay?
In the Lamsilis muscle unit, the checklist might capture ideas about variation in lure traits, selective pressures exerted by host fish, and evidence showing how these traits increase reproductive success over generations. The Gotta Have checklist is constructed as a whole class and can be developed gradually across the unit to support model construction, or co-constructed during this stage, just before students begin writing their own evidence-based explanations. In addition to identifying the key science ideas that must be included, The checklist is also used to coordinate those ideas with the evidence students have generated across tasks in Stage 3. Because it is built publicly and revisited together, the Gotta Have checklist becomes an invaluable resource for students as they transition into writing. It represents the final step in building consensus, capturing what the class agrees counts as a strong explanation and the evidence that supports it. From students' perspectives, Stage 4 is a time to pull ideas together across groups, across tasks, and across time. Students revisit how they initially thought about the phenomenon, how their ideas were challenged and refined through investigations, and how the class now understands the phenomenon as a community. This stage helps students see that scientific explanations are not simply individual answers, but collective accomplishments that emerge through comparison, critique, and negotiation. By engaging in consensus-building discussions, students learn to justify ideas with evidence, attend to differences in reasoning, and recognize why some explanations are stronger than others. Because the work culminates in shared models and public records like the Gotta Have checklist, students are positioned to see their upcoming writing not as a new task, but as a continuation of the sense-making they have already done together. Their explanations are grounded in ideas and evidence they helped develop, evaluate, and agree upon as a class. By the end of Stage 4, students have finalized group models, reached consensus across the class, and co-constructed a Gotta Have checklist that outlines what strong explanations should include. These supports are intentionally designed to scaffold the next stage of model-based inquiry, where students will individually construct written, evidence-based explanations of the anchoring phenomenon. Building consensus is where individual and group sense-making becomes collective understanding. It ensures that students move forward not just with answers, but with shared criteria for what counts as a strong scientific explanation. To learn more about model-based inquiry and see examples from classrooms, visit modelbasedinquiry.com.